day. Okay, we have learned about vector and scalar, about vector addition, vector subtraction and multiplication. Today in this class over here, I'll be solving few numericals from the chapter. Okay, so the question from in your book and my book might not be the same. Just read, listen to the question properly, and even I'll send you the question as well. Okay, this is about vector addition, how we add and how we subtract vector. So the first question is, if vector A and B, the vector A is given, question number 13, the number is 13 in my book. Please do check the question number in your book. A is 3I plus 2G and B is I minus 2J plus 3K. So this is the value of vector. A is 3I plus 2J, B is I minus 2J plus 3K. If only I is there, we need to assume that is 1. So what you have to find in the question is, we need to find A plus B. This is what we need to find, and also we need to find A minus B. So this is what we need to find. Now, for the first part, okay, for the first part, so for adding two vectors A and B, when we add vectors, when we add I, we only add it to I plus I. I cannot be added to J. Because as I have told you, I is the direction along x-axis, J is the direction along y-axis, and K is the direction along z-axis. So only the same axis can be added, not the other one. So 3 plus 1 will be 4I. Okay. Then comes plus 2 minus 2, 0. No need to write. Then the K. Over here nothing is there, so only 3 is there, so it will be 3K. So 4I plus 3K. This is the vector. Now we need to find the magnitude of the vector. So when we find the magnitude of the vector, what we do is, I have given you the formula, that is under root A square plus B square. Okay, so A square plus 3 square, 4 square plus 3 square. If we solve this, we get 16 plus 9, which gives us 25, and that will be 5. So A plus B is 5, the magnitude is 5. Now, the second part, A minus B. Now we need to subtract the vector. 3 minus 1 will be 2I. Okay. 2 minus minus 2. So when we subtract 2 minus minus 2 will be 2 plus 2, which is 4. So it will be plus 4J, and at last we have got 3K. Now to find the magnitude. Finding the magnitude process is this thing, same. Okay? So under root 2 square plus 4 square plus 3 square. So if only one vector is given, if two vector is given, if three vector is given, we need to find the magnitude. We'll add, subtract, whatever is to be done, given depending on the question. Then finding the magnitude is this part. We'll add it and we'll find the root. So this is 4 plus 16 plus 9, which gives under root 29. Okay, in a book the answer is under root 29, so keep it as it is, or else you can find this one also. Now in class 11 you can use the calculator, so it will be easier for you to do all these calculations. Okay, so this is the process. This is question number 13. Now next question which I will be solving is Question number 18. Question number 18 is, there are two vectors given and we have to find the value of C. So, in question number 18, there are two vectors which are perpendicular to each other. Perpendicular to each other means theta is 90 degrees. Keep that thing in mind. You need to think that way. So there are two vectors, which is A is I plus C j plus 5k. B is 2I plus j minus k. So over here what is given is these two vectors A and B are perpendicular to each other, that means theta is 90 degree. This is given in the question. Theta is 90 degree. Now what you need to find is you have to find the value of C. So theta 90 degree means you have to think in such a way. Now to find the value of C, this has to form an equation. That means A dot B should be 0. So for your value to be 0, theta has to be 0. So now which theta will be 0? Which cos or sine, which 90 will be 0? Cos 90 is 0. Sine 90 is 1. So we'll use cos theta. And for using cos theta, A cross B is the sine product. So A dot B is the cos product. So we will use A dot B. A dot B is actually A B cos theta. And cos theta over here is 90, cos 90 is 0. So A B cos 90. So if cos 90 is 0, this whole part will be 0. Now next is we will find A dot B. So your A is this one, right? A as this is A dot B is 2I plus j minus k is equals to 0. So A dot B is equals to 0. What you need to find over here is the value of C. Where is C? C is in the place of the vector A. Now when we do A dot B, this we will be learning in the teaching class, but over here I am just telling you how to solve the numericals. When we do dot, if dot is there in between, we can directly multiply. Okay? If there is cross in between in case of dot, then we have to use a matrix formula. That is a bit different. We will study it in the next question. So if it is dot in between, you can directly multiply, but which two factors? I and I only can be multiplied. I and j cannot be multiplied. Okay? So this will be 2 into 1, 2. Okay? Second is C into j. J only 1 is there. C into 1 is 1. Plus and plus will be plus, so it will be C over here. Then third is 5k into minus 1. Minus plus 5 into minus 1 will be minus 5 is equals to 0. Okay, simply multiplying the same factors, that is 1 into 2, C into 1, 5 into minus 1. Now why I am not writing I, j and k is, if you multiply this two, that is I into 2i will be actually 2. Why I am not writing I? Because I into I is 1. Okay. J into J will also be 1. And K into K will also be 1. That is why I am not writing I, J, K. It has been replaced by 1. Now from here we can easily find the value of C. So C minus 5 plus 2 will be minus 3 is equals to 0. C is equals to 3. So what we get is C is equals to 3. Now the final question. Last question which I am going to solve is question number 21. This is about dot product. How we multiply when there is a dot in between. Okay, and this is known as a dot product. I have been teaching multiplication of vectors in the class, and what I have been teaching is when two vectors are multiplied, the answer can be either a vector, either a scalar. Okay, so that is what we are studying, and this is one of the examples. Now question number 21. So dot is applied in between. One more thing, dot is applied in between when the solution is a scalar product. When the solution is a vector product, then we will apply a cross in between. Question number 21 is two vectors are there, A and B. A is 4i plus 3j plus k, and B is 12i plus 9j plus 3k. Now the question is, there are two vectors. Prove that these two vectors are parallel to each other. Okay, you have to prove that these vectors are parallel to each other. Parallel means if two vectors are parallel to each other, theta will be 0. Okay, so whenever we have to think in such a way, so just think like this: theta is equals to 0. It means which theta is 0? Sin 0 is 0, cos 0 is 1. So which factor is 0? Cos sin 0 is 0, so we will use the one with sin theta. So when you have to prove this, which gives sin theta? Cross or dot product? Cross product gives sin theta. So A cross B is actually AB sin theta. Okay. So if sin theta, if they are parallel, theta will be 0, which means this part will be 0. A cross B is equals to 0. Now put the value of A and B, we can easily prove that it will be 0. I have to show that it is 0. So I have to put A cross B. So when we do cross multiplication, cross product, in dot product we can directly multiply, but when we do cross product, we have to do it in a matrix way. So I over here for A is 4, J is 3, K is 1. Again for B, I is 12, this one is 9, and this one is 3. So when we do a matrix multiplication, I hope you know how to matrix multiply. If you do for this part, then you just hide this and multiply these two. Okay, you multiply this for I. So for I, you will multiply 3 into 3 will be 9. 9 into 1 will be 9. Okay, that is for I, which is done. Now next, when we do for J, we assume the J is not there over there, and we multiply these two. 12 into 1, 4 into 3. So when we do for J, and over here it will be minus J. 12 into 1 is 12, 4 into 3 is also 12. This is for J. Now for K. When we solve for K, When we solve for k, it will be this, and this will be hidden. 12 into 3, 4 into 9, which is plus k. 12 into 3 will be 36. 4 into 9 is also 36. Now when you subtract this part 0, this part is also 0, and this part is also 0. So what we get is 0. So A cross B is 0. Hence proved. This is how you prove. If you have to prove that two vectors are perpendicular, then you will do A dot B. Okay? If you have to prove that two vectors are parallel, you will do A cross B. So these are the numericals from the chapter 5, which is motion in a plane. And we'll keep on continuing with the chapter in the teachment class. Just for numericals, you can watch this video. Okay, this much for today. We'll continue in the next class. Thank you.